All right. So hello everyone, and thank you for being here. Welcome to this webinar in which we will introduce our latest asset for the market. It's a ripple antenna, and we strongly believe that it will create great opportunities for your connectivity challenges. Before moving forward, allow me to introduce both myself and Poynting Antennas. My name is Sofia Alexiou. I am Greek. I'm based in Greece, in Athens, and I am an electrical engineer and sales account manager for Southeast Europe. Poynting Antennas is a South African antenna manufacturer founded in 2001. Which specialize in creating, developing, and manufacturing wideband 4 and 5G, as well as Wi-Fi antennas. In the beginning, military and defense antennas were manufactured alongside commercial antennas and all sold under the same brand, Poynting Antennas. Having our roots in the military and defense environment really shaped who we are and what we do. Today, the two branches, military and defense and commercial antennas, have separate operations. Our only focus is to make wireless connections to perform in a more stable, reliable, and consistent manner. We do this for 5 different verticals, but today we will focus on the maritime market only. By now, you will have realized that we are interested in consistent wireless connectivity. But what makes us different? There are several important aspects in an antenna. Gain is important, and so is VSWR, for example. But there is nothing more important in the antenna than the radiation patterns. How predictable is the performance of the antenna? How stable is the connections the user will experience? Everyone will talk about profit. Everyone will be pointing out how high the gain is on your antenna, but not pointing quality over quantity, especially in the maritime environment where ships are constantly moving. The antenna must have exactly the same performance in 360 degrees around you, being truly omnidirectional. Also, at sea, vessel will pitch a roll and is necessary to control the vertical aperture of the antenna to keep mass on land within range. We develop, create, design, and manufacture our antennas through our R&D department, and our patents comes from there, of course. Furthermore, everything we saw in our datasets are actually measured antenna parameters and not results of computer simulations. The construction materials are carefully selected both inside and outside, and these make pointing antennas very resistant. Some of our antennas are E-marked, IP69K, IK10. They have plastic with UV protection and resistance to salinity. They are filled with foam, or they have an anti-vandalism design. Our antennas are developed for any environment and to last several years. In addition to that, it is in our DNA to make broadband antennas electrically optimized to provide better electrical performance in its working frequency band. By covering all these frequencies, we guarantee that all the 4 and 5G network signals in the world are captured by our antennas. Finally, we design our antennas to have almost zero margin for error when manufacturing, transporting, deploying, and using them for a long period of time. This comes from an exhaustive design process and serious quality checks at every step of the design and manufacturing of the final product. And this is the only way to ensure that each antenna is absolutely flawless. Poynting designed its first maritime antenna in 2015, almost 8 years ago. It was the Omni 291. It was initially inspired by our Omni 69, a successful indoor omnidirectional antenna. In design, mechanics and accessories were redesigned to adapt the maritime environment. Our journey in the maritime world has been a success. In the last 8 years, we have sold more than 17,000 maritime antennas all over the world. And let me point it out here that we have only had less than 10 quality complaints, and none of them were for post-deployment electrical or mechanical reasons, but they were mainly due to appearance flaws either in the antenna or in the box itself. At our company, we're experts at broadband antenna solutions, tailored to meet the unique needs of marine settings. Our expertise spans a wide array of antennas, each carefully designed to excel in various maritime scenarios. Whether you are outfitting on a luxurious yacht, a sturdy cargo ship, or an offshore platform, we have the perfect antenna solutions for you, even in the most demanding coastal environments. Our antennas provide you with the exceptional connectivity you require. Our product lineup features antenna like PAC, MIMO, only the Narval range, EPNT4, as well as Ripple and Wavehunter models. Now, I would like to introduce you the Ripple antenna. Ripple is a Poynting 5G antenna in the shape of a dome, designed to be installed on vessels in which routers can be housed. With Ripple, we can fully fit up to 4 modems, providing 4x4 MIMO coverage for cellular connectivity and 4x4 MIMO for Wi-Fi and 2 GPS. The operating frequency bands range from 617 to 7200 MHz, and the peak gain is 9.5 dBi. Ripple has a total of 16 antennas inside, all of them omnidirectional, but divided into vertical and horizontal polarization, meaning it's a cross-polarized antenna. It's very important to mention that X-polarization will increase signal reliability and double data rate due to full MIMO performance. Our infrastructure is designed to support a wide range of 5G routers currently available on the market. The interior dimensions within the dome for routers are 300 millimeters in length, 250 millimeters wide, and 110 millimeters height. Additionally, the Ripple includes a bracket with 2 levels. Ripple can be easily opened and has a very intelligent hinge, so it can be left opening during maintenance or other manipulations, facilitating the installations of routers by a single individual. The Ripple technology offers a consolidated solution featuring multiple antenna designed to accommodate forthcoming technological advancement. This technology is available into 2 distinct versions. The first, known as Ripple 8, incorporates 8 antennas, enabling 2 4x4 MIMO functionality. The second iteration, Ripple 16, is equipped with 16 antennas and supports 4x4 MIMO functionality. Regarding mounting options, Ripple comes, of course, with maritime standards, where the cabling is running through a cable gland. Also, there are 4 screw holes and 12 where you can insert the screws to mount it onto a pedestal. And we have at the bottom an innovative heat-sink patent. Moreover, Ripple has a wide band coverage from 617 to 7200 MHz, with a 9.5 dBIP gain. And what I want to mention here is that the Ripple antenna was developed from our previous experience with Wavehunter. Just like car manufacturers test new technologies and improvements in Formula One before deploying them in everyday cars. With Ripple, we challenge a lot of installation issues and we optimize the total connectivity setup with a vast reduction of coax cable length, adding cross-polarized, improving reach out achieved by the patent antenna setup, and all this within a very budget-friendly package. Other routers you like to work with, and you're all set to offer a great 4 and 5G solution to your customers. Right, so Ripple antenna is ideal for all data needs. And let me be more specific. Where does Ripple fit in? Do you want to make absolutely no compromise and spend as much time connected to cellular network as possible? Then the Wavehunter is your way to go. It may be even that it's set up paying for itself after a few months of cutting back on your satellite data. Do you want to have an easy installation, don't have a lot of room or time to run coaxial cable and can't use a crane? Then Ripple is there for you and ensures you will still get dual polarization. Is reach more important than connection stability and throughput? Or perhaps budget is a bit tight? Or even the vessel is too small for a dome like these ones? Then perhaps a setup of Omni 400 series like the 409.3 or others, or 900 series, 904 or 914, for example, can be the best alternative. And let me moving forward to the antenna applications. When do we need a Ripple? When higher throughput is a requirement, when we need reliability, stability, and consistency, when we need higher data volume for a higher number of clients served, for a crew and passengers' welfare, of course, and for range and performance. All marine vessels, big or small, need a dependable data connections. Ripple antenna excels in meeting data requirements for various uses, such as survey vessels, cruise ships, commercial shipping, yachts, offshore platforms, tugboats, and more. And moving on to the measured results. Here we can see again the frequency bands, which are from 617 to 7200 megahertz. Ripple is available in the following configurations. We have in the first column we have the Ripple 8 providing 4 vertical and 4 horizontal polarized cellular ports and 2 vertical and 2 polarized ports, and 2 Wi-Fi and 2 GNNs. And the Ripple 16 providing 8 vertical and 8 horizontal polarized ports, 2 vertical and 2 horizontal polarized port, and 2 GNNs. Here we can see the vertical cellular measured results. In the first diagram, we have the VSWR across the frequency bands, which is less 2 to 1, very, very good results. And at the second diagram, we have the peak gain across all frequency bands. Moving forward, I would like to show you now the cellular measured radiation patterns for the elevation and vertical aperture across the frequency bands, which are really exceptional results. Also here we have the horizontal cellular measured, of course, results. In the first diagram, again, we have the VSWR across the frequency bands, very good results. And at the second diagram, we have the peak gain across all frequency bands. And moving on, I would like to present you here this cellular measured radiation patterns for the elevation and vertical aperture across the frequency bands. Here we can see how exceptional the results are from 617 to 2700 megahertz. And here we have the rest of the frequencies from 3400 to 7200 megahertz, which are again very good results. Moving forward with Wi-Fi measured results, in the first diagram, we have the VSWR across the frequency bands. It's listed one very good result. And at the second diagram, we have the peak gain across all Wi-Fi frequency bands. And of course, the measured Wi-Fi radiation patterns for both elevation and vertical aperture. Here we can see the mechanical information. As you can see, the ripple total height is 496 millimeters and its diameter is 410 millimeters. Also, regarding the environmental specifications, ripple is IP65, weather, dust resistant, enclosure, UV and salt water protected for marine and coastal conditions. In addition, the ripple comes with 3 different optional brackets regarding the size of installing the router. Here we have the brackets 71, 72, and 73. Now, I would like to show you some marine installations which are really very interesting. In the first picture, we can see a survey vessel and the ripple antenna surpassed the expectation, achieving over 60 kilometers connectivity in the Baltic Sea. In the second picture, we can see the Ripple 8 on a super yacht to maximizing 4G and 5G connectivity. And on the third picture, we have a vessel in Hamburg, regular cruising the Baltic Sea, North Sea, S2 Mediterranean Sea, and the crew is spending on average 100 gigabytes more per month with the new Ripple. So do not lose sight of the shore with the Ripple antenna. I would like to thank you very much for your attention. You will receive this presentation and the marketing materials during tomorrow. Thank you all again. We hope you found the presentations informative and useful. Now, I would like to open the floor for questions. Please feel free to ask any questions you may have about the topics we covered in today's webinar. To ask a question, simply type it in the Q&A box, and my colleague Birger Hillard, who is highly expert at the maritime business, and I will answer them. Thank you again.
Thank you for the great presentation, Sophia. So let those questions come. Don't be scared. Yes. If there are any techniques that were discussed, which we've added into the Ripple, and you want to know more about it, please ask. For example, cross-polarization, what does it mean? Because if you know what it means, you can really explain this to your customer. And of course, the most important thing is always, how do I manage the expectations of the customer? What does he want to do with the internet, and what does he really expect from it? Because They will look at budget, but they need to understand, what do I buy for this? And that's a lot of times you can tackle that with just emphasizing on the techniques used and what it can mean for your connectivity. So feel free. How many horizontal degrees coverage has each of the antenna elements? That is a good question. And that's, of course, always in the technical sheet of a pointing antenna, because what you see is what you get. And as Sophia already stated, it's always true measured, true measurement. So even if they don't look 100% perfect, we put them in there because 100% perfection doesn't exist in antenna manufacturing. But a lot of brands use simulated results, and that's why they are close to perfection. So let me go into the radiation pattern of let's say, start the vertical antennas. That are the high gain antennas that will give you the furthest reach out at sea. What we can see in the technical sheet on elevation, it is about a 30-degree opening angle. So that's quite a lot. So we educated guess is that a ship rolls about 10 degrees up and forth in a normal sea. So of course, with serious weather conditions, it could be higher, but it has a 30-degree on opening aperture. Let me look at but it's for the horizontal units, because we use cross pole, horizontal and vertical. That is less important because we've turned them, and then your vertical aperture is 360. So I hope you see this in your head. So the horizontal antennas have like omnidirectional horizontal, so they have a 360 opening. And the vertical ones, which the high gains antennas for the furthest reach, have a 30-degree opening. So a very good question, and very important to look at that when you offer a maritime solution, where antennas are involved, of course, because that's very important. So you won't shoot over or under the cell tower at land. Great question, George. Thank you. Other questions coming in? Does everybody know the effect of cross polarization? Because I like to emphasize on it, because it's just such a great technique, because the cell towers at land use it. They make per frequency 2 perfectly separated channels, and to perfectly separate it, you need to separate them 90 degrees from each other. So cross pole could be horizontal, vertical, or plus minus 45. So this way they can double the capacity of the wireless link. So if we would only have one vertical antenna on the ship, you already reduce half of the capacity that the cell tower is sending out. So using cross polarization on the receiving end will make it able to receive that doubled capacity. That's one thing, because the providers do it via the cell towers. And at the other side, what happens between the cell tower and the antenna, shifts in polarizations, that happens, that's nature. So when using cross polarization, you reduce the possible loss to 3 dBi. 3 dBi is half the power. If you wouldn't do that and only have one vertical antenna and your signal hits you horizontally, you lose minus 34 dBi. And as it is logarithmic, it's 2 to the 7th. That means, yeah, that's practical isolation. So you wouldn't have anything possible that signal could mean for you. So that's really important. So cross polarization really reduces polarization mismatch. And if that cell tower sending out in cross pole, you would maximize reception and have really that double capacity. And that starts about 3 kilometers from the cell tower, that you would really experience double capacity compared to a normal, good omnidirectional antenna, but with one polarization. So that's really an important thing. I can talk for some hours, so maybe a result, Sophia, a nice result. It's not finished yet. The test is still going on. We have we have several ripples out there that were the first MVPs, the minimal viable products. And we had one reporting a trip from Barcelona to Mallorca, was on a yacht. and they only lost, what was it? Connectivity about after 95 kilometers before picking it up again. So they lost about 10 to 15 kilometers of 4G from the trip to Barcelona to Mallorca with the Ripple. And it really surprised them, but we were expecting it, but you can never say you will reach that distance because there are so many parameters you cannot control. And the one in the Baltics we are using, the third example, if I'm right, is Sophia. That is a ship that's always going from the Baltics around Denmark, the Netherlands, Belgium, France, going past the Gulf of Biscay to the western part of Portugal and Spain. And of course, they now use more. The crew is really satisfied with the connectivity. They use more, but overall, they're very happy and happy to pay for more data for the crew. What they've seen, they have an increase on connectivity on the 4G of 86%. So they're now 86% of time connected to 4G. So if you know the Gulf of Biscay between France and Spain, that's probably where they lose connectivity because it's really a big distance. But they were at 65% of connectivity. They're now at 86%. So that's a very good result, something we also expected. But yeah, it's always nice to hear from the people using it. So it can really mean a lot. And yeah, of course, you can Ripple 8, Ripple 6. That means you have 2 5G modems in there or 4 5G modems in. So it's really making use of all that extra bandwidth because you have more modems. And more modems means more possibility on bandwidth. So and whether you then use bonding to make it really reliable or like load balancing to really steer the traffic, that's up to you. That's where your knowledge is, of course. So but maybe when you would have more time and you really want to discuss a project, don't hesitate to contact us. We're here to advise and to consult on every challenge you may have. And if you want us in a customer meeting, we're happy to do that, to really explain what WaveHunter would mean, what Ripple would mean, what the 914 would mean, what the 493 would mean, what would be an ideal setup, what are the watchouts. For example, one of the very important things is looking at the total wireless capacity, and signal to noise ratio is a very important one there, because if there's a lot of interference and noise, it will have a really big impact on your setup, your total setup. So watch out for S-band radars, because they're like in the 3000 megahertz, which is like the lower 5G, upper 4G frequency, and they are high bursting their power. So they can really have an impact on the antennas when it's in the scope of the S-band radar. Of course, metal infrastructure can always create scattering effects on the signal, so that will mean it won't hit your antenna in full capacity, because before it hits your antenna, it's being scattered by the metallic infrastructure. So all these things, you need to watch out for that. And that's a really simple thing. When you do the installation, before you leave the ship, look at the signal parameters, RSRQ, RSRP, signal to noise. If you see they're good, that means you have done a clean installation, meaning there's nothing interfering with it. So that's good. Because then later when they report something, you can always check, hey, this was, when I left, this was this. Maybe something changed on the vessel, but they didn't tell you. So that's not your mistake. They changed something, but at least you can ask, hey guys, did you change something in the surroundings of the antenna setup? They could say, hey, we installed this or that. Oh yeah, we have a new S-band radar. And then the bells start ringing. So that's a good thing. RSRP, RSRQ, signal to noise. You can easily go into the user interface of the routers you use, watch them, copy, paste, screenshot, put it in the folder you keep on that vessel, for example, in the dossier you made, and you have something to watch back on when they report maybe an issue. Yeah. So I see another Q&A. No. What is the offshore range comparing to WaveHunter? Haha, big question. Well, of course, it's not only WaveHunter Ripple that will have a great impact on offshore reach. Of course, weather conditions, position of cell towers, position and the height on the vessel itself. If you can get the top piece of the mast with a Ripple on it, will of course, or a WaveHunter. Now, really comparing WaveHunter to Ripple, that is understanding what's on distance. What signals are still out there at, let's say, 70 kilometers? And we need to know the higher the frequencies, like 5G won't travel that far. We would say like 2 to 3 nautical miles, so that's 4 or 5 kilometers out at sea. So the further you go, let's say around 25 kilometers, 30 kilometers, 40, 35 kilometers, you will still have higher 4G. That means 1800, 1900, 2100 maybe. And all depends. This is theoretically with clean weather, sun, no waves, whatever. So no fog, no rain or etc. So if you go up to 40 to 45 nautical miles, you're close to 70, 80, 90 kilometer, which it can happen that there are still signals there. And of course, the curving of the Earth, we're not living in a flat world. What you need to look at, lower frequencies have higher wavelengths. And it's a physical fact that longer antennas will perform better on longer wavelengths, meaning lower frequencies. So looking at the separate antennas we use within the Ripple and within the Wave Hunter, you need to know that on the lower frequencies, 700-800 megahertz, there's a difference about 3.5 dBi of gain, which the Wave Hunter has more because it uses directional antennas. The Ripple uses omnidirectional antennas. What does that mean on reach? To make a small comparison, on the higher wavelengths, so the higher frequencies, the higher frequencies, 6 dBi, a difference of 6 dBi would mean twice the distance out at sea. So we have here an increase of 3.5 dBi, Wave Hunter compared to Ripple on these very long distances. So Wave Hunter, it's hard to put a number on there. But let's say if you have in a position where the Ripple will still have 70 kilometers, let's say Wave Hunter will probably go up to 85, 90 kilometers and even get more out of that signal because it also has 2 extra polarizations. It has 4 polarizations. And the other effect you need to take into account is that Wave Hunter uses sectors with directional antennas. A directional antenna will reduce, of course, noise and interference. Why? It only looks in one direction. An omnidirectional antenna looks in 360 degrees. So if there's interference coming from the back, it will pick up some of that interference, where a directional antenna won't. So an exact number I cannot tell you, but it will. Sorry, my Alexa was giving me a difficult time. So in distance, it's hard to say what it will give. We have examples of 75 kilometers still having 70 Mbps download speeds on a Wave Hunter. On Ripple, that probably will be more like 40-ish Mbps down. So it's a little bit hard to compare on distance. Wave Hunter will have that more distance. How far? It depends a little bit on where you are, and it's hard to say. It will pick up on larger distances because of its higher gain on those low frequencies. And it will also, because of the 4 polarizations, get more out of that still available signal out there. But that's hard to say. Someone that really puts a number on it, he's a little bit lying. So it's hard to say. But it's a very good question. So Wave Hunter will really get the most out of it on bandwidth and on reach. And Ripple is a very good one on reach. But yeah, a little bit less than Wave Hunter. Yeah. Hope this answers your question, but it's not an easy answer to give. Any more questions? Don't hesitate. But if not, and maybe this night when everything was congested about the information we gave, some questions come up, don't hesitate to reach us via our distributing partners or directly via us, via Poynting sales inbox, or if you have our direct email addresses, no problem. If you want to organize a one-on-one to discuss a certain project, as said, please don't hesitate. Reach out to our partners, reach out to us. We're happy to advise and consult. And we have a lot of use cases and a lot of happy customers. So that's also always nice to hear. And most of the time we hear it from you guys that sell or install those antenna solutions together with the correct router setup. So Sophia, I give it back to you. Hope I didn't take too much time of you. So Sophia.
Thank you, Birger, a lot. Thank you for all the questions. that you put at our Q&A box. Please, as we here told earlier, please feel free to contact us directly or through our distributors if you would like to know more about the antennas in general, about all the model and the ranges. I would like to thank you all again for attending today, and we hope to see you again soon at our next webinar. So I wish you a lovely day and a lovely rest of the week. Thank you all. Thank you.